This session is going to be on sentiment analysis with TensorFlow. So basically, it's actually not a standard sentiment analyzer. It's going to be a special sentiment analyzer that is actually dealing with class imbalance data. So class imbalance, it's a very common and pesteros problem in data science. So it's actually really good to learn about how to combat class imbalance, during data manipulation, as well as the modeling. And this is also, I would like to give a quick shout out to my book, which is TensorFlow 2 in Action. So this session is done as a part of the book TensorFlow 2 in Action. So if you purchase the book, you will see that on chapter 8, chapter 9, it will be about sentiment analysis with TensorFlow. So you might be wondering why you would purchase TensorFlow 2 in Action. So I'll just give you a quick few highlights about the book. So it discusses all the popular deep learning models like computer vision models like CNNs, and then models that are used in NLP tasks like gated recurrent units, long short-term memory units, and also the groundbreaking new family of deep learning models called transformers. So we dive into in-depth discussions on these topics in the book. So if you're interested, you can have a look. And then we also talk about these models in action in real world, like in computer vision tasks like image classification. It's not just about the modeling side. It also discusses other important aspects like creating the data pipeline. So it's almost like that ETL component of your data science workflow, where you bring the data from the disk or some source into the memory and then into your model. So TensorFlow has so many different functions and facilities to create complex data pipelines that suits any type of data. So we'll be discussing those kind of important aspects as well. And then finally, something that has emerged recently and has gained a lot of attention is something called MLOps, which is derived from DevOps. So MLOps talks and focuses on monitoring and deploying your models. So basically, as you create better and better models, how do you seamlessly provide the service or like the ability to use those models to your customers seamlessly without interrupting their day-to-day interactions. So that's an important aspect as well. So yeah, that's what's going to be discussed. And a little bit about myself. So I have a PhD in machine learning, which is from the University of Sydney, Australia. And I've been working as a senior data scientist for QB Insurance, which is a financial institution in Australia, for about 3 years now. I've been in the publishing space for around 3 years with various publishers like Manning, Pat, and DataCamp. So to the right, you can see some of my profiles. For example, on the top, the GitHub profile. To the left, to the right, the Medium profile. And one of the courses I did on DataCamp is on machine translation. And I'm also in other various contributing spaces, like on Stack Overflow, I can actively contribute for TensorFlow. I have a reader base around 1.6K on Medium. If you would like to join that, just go to @Tushvi89, and on GitHub around 220 followers. So that's a little bit about me. Great. So before we dive into the code, if you want to code along with me, I would suggest installing and making sure these packages and languages are installed. For this one, we will be using Python 3.6, and then we'll be using libraries like pandas version 1, NumPy version 1.18, scikit-learn version 0.22, TensorFlow version 2.2, Jupyter version 1, and then an NLP library with various NLP functionality, version 3.4. But if you don't have this installed, just stick with us. I'll just be walking you through the code, and then later you can download the code from GitHub. thing before we dive into the actual code and the discussion that's lined up for today. The main takeaways from this session will be, first, we will understand what is sentiment analysis and what it's actually helping us to achieve in actual world. Because sentiment analysis itself is, it's a very generic task. So it doesn't answer any specific questions, but you can leverage the results from the sentiment analysis to answer some of the important questions, as we will see. And then we'll see how we can load some JSON data and detect whether class imbalance is present there. And then we will pre-process and clean the text with a computational library or a data scientific tool called pandas, and then an NLP library called NLTK. Then we will focus on creating subsets of data from imbalanced data, because we need a training set, we need a validation set, and we will need a testing set. So we will explore a little bit about what kind of options are available to us to perform this task. Then we're going to discuss how to choose some of the data-specific hyperparameters that will eventually help us to define the model in a principled manner, not just random, but in a principled manner. Next, we will talk about defining a tokenizer, which is a part of our workflow, which is responsible for converting words or actual strings to word IDs, because we need to do that. And then we will define a sentiment analyzer, which has an LSTM and few dense layers. And then we will talk about training the model with attention to the class imbalance and how to make sure the model knows about class imbalance while training. And finally, we will evaluate the model to see if it can fairly identify various different sentiments in the data set. Great, so this will be the takeaway. So let's focus on the first takeaway. What is sentiment analysis? So let's say we have a platform where we sell various products, like, let's say, Amazon. So they have products like electronics and garden products, beauty products, toys, and various other stuff. So each this colored square, you can think of it as a product. There's 4 customers, and these customers interact with this platform. So by interaction, I mean they mostly purchase products, and then they will leave a review later about telling how they feel about that product. So let's say we have 4 different customers here. So 2 customers, they are really happy about what they purchased, and 2 customers who are not so happy about their experience. So the first customer who has purchased a pair of gloves, say, gives 4 stars. This is a great pair of gloves. Keeps my hands dry for hours. And then the other person who has given 5 stars says, amazing pair of headphones. I'm going to buy another pair soon. Then we have the more unhappy customers, where one gives 3 stars, who says, it's not the best plant pot. There are minor water leaks. And then you have a person who gives 1 star, who says, well, absolute garbage. I wouldn't even recommend this to an enemy. So you can see that various customers feel quite differently about different products. And all of these reviews, they're going to be stored in a database in the backend of that platform. And then using the data stored in this database, you can perform sentiment analysis. So sentiment analysis is basically given a review, quantifying how that customer is actually feeling. So this quantification is usually a value between 0 and 1, where 1 means the person is really happy, and 0 means the person is very unhappy about the product. That quantification forms the foundation for sentiment analysis. So once you are able to quantify, how customers are feeling, you can answer some of the important questions, like which customers are actually unhappy and what are the most common reasons that upsets them, or which products or brands tend to be most negatively perceived, or even which vendors perform the worst. Answering these questions will help you to grow your customer base and even promote high-quality vendors and high quality products more to your customers, which will again feed back into growing your customer base, because the customers will now see more high quality products than poor quality ones. So this is essentially what we are trying to do here, to get this square established so that we can answer these questions later if you're a business. Great. I think we have enough to dive into the code now. So let's go into the code. So this code, if you want to have a go later, that if you don't have the environment prepared yet, or like for some other reason you want to have a look later, you can use this link, which is github.com/THUSHV89/manning_TF2_in_action/tree/demo/Twitch. So you can go to this link and download this Jupyter notebook and have a go whenever you feel like later. Also, as I said, this is a part of the TensorFlow 2 in Action book. So you can see the book at www.manning.com/books/TensorFlow in Action. But you could also get all the code that is on the book for free if you go to the link that is given here in GitHub. So github.com/THUSHV89/manning_TF2in_action. So if you go to that link, you can download all the code that is there for all the chapters, because that will be always available freely. So we can dive into the code. So first, what we're going to do is we're going to import a bunch of libraries. So you can see TensorFlow is imported, pandas is imported. We're going to use NLTK, NumPy. And here we do some of the housekeeping that we need to do before we start any modeling. Important thing we're doing here is fixing the random seed. Why is this important? Well, the randomness is an essential part of a data science workflow. But the randomness needs to be used very carefully. You can't have the randomness changing every time you run your code. That means, like, if that happens, your results are not reproducible, which is a problem. So in order to make your results reproducible, you have to fix your random seed. So different libraries use different ways to fix the random seed. So basically, this one fixes the random seed for some of the common libraries like NumPy, TensorFlow, and the Python built-in random package. So we're going to fix the random seed to 4321. You can use any value. And then now, after this, no matter when you and how you run things, it will give the same results. So we are going to use a data set which is available from this link. So if you run this code cell, you will get that file, download it, and then extract it onto your data directory. So let's see what this file actually contains. So once you run this cell, it will create a data folder in your code repository and download the data in there. So you can have a look at what it actually is. So mind you, this is a very large file for a JSON file. So if you be careful when you're opening it, because it can also freeze the computer. Usually, if you use Notepad++, it's fine. So we will use Notepad++. All right, so here you can see what the data is. So you can see an overall score, which is the number of stars that were given by the reviewer, whether it's a verified buyer or not, when it was reviewed, and then the actual review text, which is what we are mostly concerned and what we want. So you can see it just keeps going. So each record will have this information in that JSON file. So this is what we're essentially going to use. Great. So now we have downloaded the file. We are all ready to go. We will use pandas to analyze and detect the class imbalance as we discussed. So all you need to do to load this data is call this line. So pd read JSON, you give the path to your JSON file, and then you set a very important argument. JSON files can be in various different formats. There's a set of common formats that JSON files fall into, and depending on the format it is in, you have to select this parameter. Otherwise, Pandas doesn't know how to actually format your data after loading it, so it will return an error. So as you saw in our text file, each record is a different line. So because of this reason, the most appropriate argument is records. So if you set records, it will load the data frame correctly. So review.df will contain all the reviews that we have. And we will go and focus on these particular columns only. So overall says the number of stars that were given. Verified says whether it's a verified buyer or not. Then review time and the review text. You can do a review.df head to see the top samples in your data frame. So basically, a data frame is just a matrix where you have column names on the top and you have an index as the rows. So that's all to it. It's a matrix that is much more readable than an actual matrix. And it can contain different data types for each different column as well. So it's a more versatile version of the matrix. And then we will do a little bit of cleaning. So what we will do is we will remove any reviews that don't have a review text, because ultimately, if the review text is empty, you can't perform sentiment analysis. And then we will remove any reviews which has empty strings in them. So that will get rid of a few reviews, like it's actually more than 100, below 200. And then now we are off to detecting the class imbalance in this data. So it's very easy to detect the class imbalance. All you have to use is this value counts function. What value counts function does is when you give a column to it, it will count different values in that column and give you a key value pair where the key is the actual value and how many instances from that value are present in that data set. So for example, if you look at the verified column, you will see that it has 332,000 verified customers and 164 unverified customers. Just to keep the integrity of our modeling task, we will use only the verified buyers, just to avoid that noise in our data set. We are actually quite confident that there's a lot of verified customers here, so we're not going to lose that much data by removing the unverified ones, so it's fine. The next thing we're going to do, we're going to get only the verified customers. So you can do review.df, so log stands for location, and then review.df verified. So review.df verified is a Boolean. So if you pass a Boolean to this log function, it will extract the so that value counts on the number of stars that were given. So this essentially feeds into our class. So you can see here, there's way too many 5-star reviews. So 222,000 reviews, whereas in 4-star ones, 3-star 27,000, 1-star 15,000, and 2-star 12,000. So you can see there's a huge class imbalance here. So yeah, essentially this is what we're going to combat in our model. Another thing we will do in order to make our classification task easier is we will, instead of trying to predict the number of stars, we will try to predict a sentiment. Basically, we'll predict 0 or 1 for each given review, depending on whether that review conveys a positive sentiment or a negative sentiment. So the way we will do it, we will map all the 5 stars and 4 stars to value 1, and we will map 3, 2, 1 to 0. So to do that, you can use get the overall number of stars given, and then you can call the map function and pass in a dictionary. This dictionary will have key value pairs. This dictionary will have key value pairs. The key will show the actual value you have in that column, and the value will show the value that you need that existing value to be mapped. So we want 5 to be mapped to 1 and so on. And then you can do another value counts on this new data. And we will assign this to something called a label, because this is the ultimate label we're going to use.